Coming all to the course Database Management System. Myself, Ahmad Asifuddin Mondal, Assistant Professor, Department of Computer Science and Engineering, Narula Institute of Technology. And this is lecture number 24 of this course. In this lecture, I will discuss about the concept of second normal form, in short 2NF, and then I will discuss about third normal form, in short it is known as 3NF. So second normal form 2NF. As usual, in normal form basically analyze the relation based on their functional dependencies and primary keys. So in case of 2NF also, we normalize a relation in 2NF by analyzing the functional dependency and primary key. But before discussing 2NF, before defining what is 2NF, we have to know the basic terminology. The first point is prime attribute. Now what is prime attribute? Prime attribute is not a primary key. I am telling what is prime attribute. Prime attribute is an attribute which is a member of the primary key. So again I am repeating, prime attribute is an attribute which is a part of primary key, and the other term is non-prime attribute. Non-prime attribute is the attribute which is not a part of primary key. So let's take an example. Suppose this is the relation. So SSN is the social security number which is unique for each employee. Then P number is the project number. Hours, E name is the employee name, P name is the project name, P location is the project location. If you consider that relation, whether SSN can be considered as a primary key, first we have to decide which one is the primary key. So can we consider SSN as a primary key? No. Why? Because in EMP underscore PROJ, in that relation, we are assuming that based on the data set that each employee can work in multiple projects. So only SSN, which actually represent a particular employee, so each SSN means each employee works in multiple projects. So that is, the domain of SSN is not unique. So if you look at the first two entry, 1 2 3 4 5 6 7 8 9 is in the first record the value of SSN is 1 2 3 4 5 6 7 8 9. In the second record again the SSN value is repeating 1 2 3 4 5 6 7 8 9. So that means the value is repeating, that is why SSN cannot be a primary key. In the first record, the employee whose SSN is 1 2 3 4 5 6 7 8 9 works in a project number 1, as well as in the second record the same employee works in another project whose project number is 2. So SSN cannot be considered as a primary key. So in that case, what should be the primary key? If you combine the attribute SSN along with the project number, so these two forms a primary key. So let's check whether as a combined SSN and primary number project number, can they be able to uniquely identify a specific record. Let's check. Suppose select a record whose SSN is 1 2 3 4 5 6 7 8 9 and who works in project number 1. So check whether this selects only a specific record or not. Yes, the SSN is 1 2 3 4 5 6 7 8 9 and who works in a project number 1 is then that means it will identify only that particular record only. So in that case, SSN along with project number as a combined, they can be considered as a primary key, and in that case the primary key which consists of more than one attribute is known as composite primary key. And again, for further clarification, can we tell only the P number can be considered as a primary key? No, because with the help of P number we cannot be able to uniquely identify a particular record. For example, suppose select a record whose P number is 10, then what happen? the P number 10, if you specify the P number 10, then it will identify this record, then that record also. That means with the help of P number, we are not able to uniquely identify a particular record. So as a combination, SSN and P number are considered as a composite primary key. Now the point is prime attribute and non-prime attribute. As I have mentioned, prime attribute is an attribute which is a part of primary key. So P number, now first SSN. SSN is a prime attribute or not? Yes, SSN is a prime attribute because the attribute SSN is the part of that primary key. Next, check whether P number is a prime attribute or not. Yes, P number is a prime attribute because P number is a part of this primary key. Now non-prime attribute. Suppose non-prime attribute is the attribute which is not a part of primary key. Suppose consider hours. The attribute hours is a prime attribute or non-prime attribute. Hours attribute is not a part of this primary key. This is the primary key, but hours is not a part of composite primary key. Hours is not a part of composite primary key. That is why hours is a non-prime attribute. Similarly, ename. Ename is not a part of this primary key. So ename can be considered as a non-prime attribute. Same is applicable for pname and plocation also. So this is the concept of prime attribute and non-prime attribute. Next, full functional dependency or fully functional dependency. So an FD Y arrow Z where removal of any attribute from attribute set Y means that FD anymore does not hold, then we say that Y arrow Z is full functional dependency. That means we can say that Z is fully functionally dependent on Y. For example, the hour attribute, this hour is fully functionally dependent on SSN and P number. Just go back to previous slide. So hours, so SSN comma P number, arrow hours means the attribute hours is fully dependent on SSN and P number, and this functional dependency is fully functional dependency. Why? Because neither hours is only dependent on SSN or hours is only dependent on P number, rather hours is dependent on both SSN and P number. So let's check whether it is true or false. So if you consider that example, we cannot write that way, means hour cannot be functionally dependent on SSN. This means hours is a functionally dependent on SSN. But if you analyze the data set, we can say that for a particular SSN value, there is a multiple hours. So you cannot write that way. So it is not fully functionally, so it is not a functionally dependent. So we have to strike it out. That means hour is not a functionally dependent on SSN. Why? Because for a particular value of SSN, you are not getting unique value of hours. For example, if we provide SSN value, say 1 2 3 4 5 6 7 8, we are not getting unique value of hours, we are getting multiple values. So we are getting 32.5, 7.5, all this. Or also if we provide the SSN value 333, 44, 555, then we are getting hours value 10. Here we are getting a single value, but in that instance we are, for a single SSN we are getting multiple value. Similarly, in that example, 98765431 is the SSN value, and that particular employee works for 20 hours as well as for works in 15 hours also. So hours is not a functionally dependent on SSN. Similarly, hours is not functionally dependent on P number, so you cannot write that way. You have to strike it out. Let me strike it out. That means hours is not functionally dependent on p numbers. Again, you can check it from the given data set. If you provide project number 1, then it has corresponding hours value is 32.5, as well as for this one we have 20. So for particular project number value, this is not selecting a unique value of hours, rather it is selecting multiple value. But as a combination of SSN and project number, it uniquely identifies hours. Means though hour is not functionally dependent on SSN, so hours is neither dependent on SSN nor hours is dependent on P numbers, but hours is fully functionally dependent on SSN and P number. That means we can write that way. This one, hours is fully dependent on SSN and P number, means hours simultaneously depend on both SSN and P number. Let's check whether it's working or not. Suppose the SSN value is 1 2 3 4 5 6 7 8 9 and P number is 1, then check whether that coupled value are uniquely identify a specific hours or not. Yes, it has only one hours value, which is 32.5. You can check any one of the data. So this is called fully functional dependency. That means hour is, as the hours attribute is dependent on both SSN and P number, and that kind of dependency is known as full functional dependency. That means hour is fully dependent on SSN and P number. Now check whether ename is fully functionally dependent on SSN and P number or not. That means, can we write that way? SSN comma P number arrow ename. That means we can write it that way if ename is dependent on both SSN and P number. So let's check with the example. Now as we know, every employee name has corresponding unique SSN. That means in that case ename is only dependent on SSN. That means if you provide only the SSN value, then it will be able to select a specific ename record. For example, if you provide the SSN value is 1 2 3 4 5 6 7 8 9, then it always going to select a unique value of ename, which is mid John B. And take another example. If you provide 334 333 44 555, if you provide that SSN value, it always going to select a unique employee name, which is Franklin Ong. So we can say that employee name is only dependent on SSN. Ename is only partially dependent on SSN. Ename is not dependent on P number. So that means you cannot write that way. Ename is not fully functionally dependent on SSN P number. Why? Because ename is only dependent on SSN. It's sufficient. If we provide SSN, we will be getting unique value of ename. So P number is not required. So ename is not fully dependent on this composite primary key. So these are the concept of prime attribute, non-prime attribute, and full functional dependency. Now discuss about the second normal form. Now second normal form, now is in short is known as 2NF. Now a relation, we can say that a relation is in 2NF if it is in already in 1NF and all non-prime attribute is fully functionally dependent on composite primary key. So again I am repeating, a relation is in 2NF if it is already in 1NF and all non-prime attribute is fully functionally dependent on composite primary key, then only we can say that a relation is in 2NF. And if that particular condition not holds, then what happen? Means if non-prime attribute is not fully functionally dependent on composite primary key, then that means the relation is not 2NF. And then what we have to do? Then we have to move that non-prime attribute which is not dependent, which is not fully dependent on primary key. We have to move that non-prime attribute with the key attribute on which they depend on into a new relation. So we have to form a new relation, and the new relation will contain the non-prime attribute which is not fully functionally dependent on composite primary key along with the key attribute on which they depend on. So it will be much more clear if we take an example. So move to the next slide. Suppose this is the relation, this is the base relation emp underscore proj. Suppose someone has designed that database or relation in that way, which consists of some attribute. One of the attributes is ssn, social security number, p number, hours, ename, pname, p location. As I have already mentioned that in that example, ssn cannot be a primary key because assumption is that particular ssn means a particular employee can work in more than two projects. So hence ssn cannot be a primary key. As a combine, ssn along with p number become a primary key. That means emp underscore proj, in that relation we have a composite primary key. Composite primary key means the primary key which consists of more than one attribute. So here the composite primary key is ssn and p number. So ssn comma p number, it's a composite primary key. Now these three functional dependency are already defined in the emp underscore project. What does it mean? Arrow towards hour from ssn and p number. That means we can term it as a hours is fully functionally dependent on ssn and p number. Now fd2, what it says, ename attribute, the arrow towards ename means ename is functionally dependent on only ssn. fd3, pname and p location, arrow towards pname and p location means these two attribute is only functionally dependent on p number only. So these three fd are defined. So based on condition of 2nm and based on this functional dependency, you have to analyze whether this relation is in 2nf or not. So if we recap what is in 2nf, if we recap if a relation is in 2nf or not, first of all the relation should be is in 1nf, and then if all non-prime attribute is fully functionally dependent on that composite primary key, then we can say that is in 2nf. Already the relation is in 2nf. Why? Because each attribute in that relation, it disallows the multi-valued attribute. So that the relation is already in 1nf, and then we have to check whether all non-prime attribute is fully functionally dependent on this composite primary key or not. Let's check. Now hours is a non-prime attribute. Why? Because the hours attribute is not a part of composite primary key. So our hours is a non-prime attribute. Ename is not a part of this primary key, so ename is a non-prime attribute. Similarly, p for pname and p location also, they are also a non-prime attribute. So we have to check only for these four attributes. So first check whether hours is fully dependent on this composite prime attribute or not, primary key or not. Yes, hours, as the fd1 suggests, hours is fully dependent on both ssn and p number. So only that, also that means this part is okay, no problem with that. So, no problem with that. But if you look at the attribute ename, there is an array towards ename, and based on fd2 we can see that the attribute ename is only dependent on ssn. So ename is the non-prime attribute, but that non-prime attribute ename is not dependent on both ssn and p number. Rather, ename is only dependent on ssn. That means we can say that due to fd2 it is not in 2nf, it violates 2nf. So what we have to do, we have to remove that particular non-prime attribute which is not fully dependent on composite primary key. You have to move that attribute along with the key attribute on which it depends on. Ename is only depends on SSN, so we have to make a separate relation. So we have create another separate relation where we included the non-prime attribute along with the key attribute on which it depends upon, so SSN and ename, and SSN becomes the primary key, so FD2 is holds here. And other relation was hours is fully dependent on SSN and P number, so it becomes hours is dependent on SSN and P number. This is another relation where primary key obviously is the composite primary key SSN and P number, FD1 holds. And next, check whether P name and P location, these two are the non-prime attribute, and again these two non-prime attribute is not fully dependent on both SSN and P number, rather these two are non-prime attribute is only dependent on P number, so partial dependency is there. So again this is violating 2NF, so we have to move P name and P location into a separate relation. So P name, P location are moved to separate relation along with the key attribute on which they depend on. So it depends on P number, so we have to include the P number attribute also. So this is the third relation. And here as per FD3 we can say that P number, as per FD3 we can say that P number uniquely identifies P name and P location, that is why P number becomes the primary key. So this was our base relation, and from base relation, after analyzing whether it is in 2NF or not, and then once it is found that it is not in 2NF, we normalize it into 2NF, and the base relation is breakdown into 3 sub relation. So that is how we can analyze whether a relation is in 2NF or not, and then we can convert it into 2NF. Next, move to the next topic, the 3NF. But before discussing the concept of 3NF, we have to know the terminology transitive dependency. So what is transitive dependency? Is one kinds of functional dependency. Suppose in a relation R, two functional dependency are defined. One is x arrow y and the other one is y arrow z. So suppose in a relation two FDs, two functional dependencies are defined, x arrow y and y arrow z. So x arrow y and y arrow z is already defined. These two functional dependencies are hold on R. Then we can say that x arrow z also hold on that relation. So transitive dependency means if two functional dependency are given, x arrow y and y arrow z, then we can say that x arrow z is also true. So simple, x arrow y holds and y arrow z holds, that means x arrow z also holds. This is known as transitive functional dependency. Suppose in a relation, suppose SSN arrow D number is defined, means department number is dependent on SSN, means a particular SSN, a particular SSN is the social security number. So that means a particular employee works in a particular department. So D number is dependent on SSN, this FD is defined, as well as DMGR SSN is dependent on D number, means DMGR SSN means department manager SSN is dependent on D number. Suppose a particular department has a specific department manager whose SSN is DMGR SSN. So DMGR SSN is dependent on D number. So these two functional dependency are defined. Then from these two functional dependency we can derive another dependency, and we can say that SSN determines DMGR SSN. So we can write this. So DMGR SSN is functionally dependent on SSN. We can derive this dependency if these two dependency are given. So we can say that DMGR SSN is transitively dependent on SSN. So again I'm repeating, D number is dependent on SSN and DMGR SSN dependent on D number. If these two holds, then we can say that DMGR SSN is transitively dependent on SSN. That means it's a kind of chain kind of relationship. And if you look at the next example, SSN arrow ename is a non-transitive. Why? Because since there is no set of attribute x where SSN arrow X holds and X arrow enum holds. There is a direct link, direct relationship between enum and SSN. Enum is not functionally dependent on SSN via some other attribute. They are directly related. But here DMGR SSN are dependent on SSN via D number. That is why DMGR SSN is transitively dependent on SSN. So this is the concept of transitive dependency. So let's discuss about 3NF. In short, it is known as 3NF. The full form is third normal form. A relation schema R is in 3NF. First of all, if it is in 2NF and no non-prime attribute is transitively dependent on other non-prime attribute. First, we can say that a relation R, again I'm repeating, a relation R is in 3NF if it is in 2NF and no non-prime attribute is functionally dependent on other non-prime attribute. This is the one criteria we can check, by which we can check whether a relation is in 3NF or not. Also, there is another aspect is that a relation is in 3NF if there should be no transitive dependency of a non-prime attribute on the primary key. This is the another aspect by which we can analyze whether a relation is in 3NF or not. Suppose in a relation X arrow Y holds and Y arrow Z holds and X is the primary key. Now it is a problem, it will not be a 3NF if Y is not a candidate key. But if Y becomes a candidate key, then there is no problem with the transitive dependency. Let's take an example. Before going to an example, another criteria based on which we can say that a relation is 3NF or not is that a relation schema R is in 3NF if for whenever every functional dependency X arrow holds in R, then either X is a super key of R or A is a prime attribute of R. If any one of these condition holds, then also we can say that a relation is in 3NF. So again I am repeating it. Based on three criteria, or three way, we can say that a relation is in 3NF. First one, a relation is in 3NF if it is in 2NF and no non-prime attribute is fully dependent on other non-prime attribute. Second, there should be no transitive dependency. This is the second alternate way to check whether it is 3NF or not, is that there should be no transitive dependency of a non-prime attribute on the primary key. And the third, a relation schema R is in 3NF if whenever in functional dependency X arrow holds in R, then either X is a super key of R or A is a prime attribute of R. So by this three way, you can follow any one of the way to analyze, check whether a relation is in 3NF or not. And now consider an example. So EMP underscore DEPT contains this set of attribute: SSN, social security number, employee name, birth date, address, D number is the department number, D name is the department name, and DMGR SSN is the department manager SSN. And assume that each employee works in a single department. So here SSN can be considered as a primary key. If you specify SSN, it will be able to uniquely identify a total set of record, as every employee has a unique SSN. An assumption is that each employee works in a single department. So SSN is the primary key. So these are the functional dependencies, those are defined. So birth employee name, arrow towards employee name, towards birth date, and towards address, and towards department name from SSN. That means employee name, birth date, address, and department number all are functionally dependent on SSN. That means this symbol can be represented with that way. Let me write it down that way. SSN arrow ename should be ename, let me correct it. Okay. So it should be a ename. So SSN arrow ename comma b date comma address comma d number. That means ename, birth date, address, d number, they are dependent on SSN. And if you look at this part, dname and dmgr ssn, these two attributes are depends on only d number, because department name and department manager ssn are only dependent on department number only. So here the primary key is SSN is the prime attribute, and rest of the other attribute are the non-prime attribute. Now the relation is in 3NF if no non-prime attribute is functionally dependent on other non-prime attribute. But here the d name, dmg or ssn, these two non-prime attribute is functionally dependent on another non-prime attribute. So so that means for this part it is violating 3NF, it is not in 3NF. Again I am repeating, these two non-prime attribute dname and dmg or ssn, these two non-prime attribute is functionally dependent on another non-prime attribute, so it is violating 3NF. So that part has to be removed from the relation and placed in another separate relation. So this is the separate relation that we have created, dname, dmg, ssn, these two included along with the attribute on which they depend on, which is d number, and definitely it will become the primary key d number. And this part is okay, because non-prime attribute birth date, address, department number, employee name, all are dependent on primary key. They are not dependent on non-prime attribute, they are dependent on prime attribute. So this part is okay. So this is from another part. So the base relation is breakdown into two separate relation. This is relation 1 and this is relation 2. So that is how we can analyze 3NF and make it into a 3NF. Now already we have checked we have analyzed the relation whether it is 3NF or not based on our first criteria. Now check the same relation with that criteria. We can check the relation, analyze the relation whether it is 3NF or not based on any one of the three which I have explained. Now let's check it with that attribute. So these two FDs are defined over here. So first check with data FD. So relation it will be a 3NF if that functional dependency here this, suppose this is x, this is a, so either x is a super key, means either SSN is a super key or this one is the prime attribute. Here in that case, yes, obviously SSN is a super key. So that means due for this functional dependency it's okay. So that means that part is okay, it's not violating the 3NF. But if you consider that part, means functional dependency, if you consider this one, d number arrow dname comma dmg ssn, where this is the x and this is the a. So here d number is not a super key, or neither this one is a prime attribute, so this is violating the 3NF. So for due to this functional dependency it is violating 3NF, so you have to remove that functional dependency and place them into a different relation. So that is how we can analyze a relation is 3NF or not by any one of the three criteria that I have mentioned. Next, and this is for your home task, you can copy it down. Suppose this is the base relation given, property ID, county name, lot number, area, price, tax rate, and 4 functional dependencies are given. Now you have to analyze the relation and normalize the relation it in up to 3NF. That means you have to check first whether the relation is in 1NF or not. If it is 1NF, then you have to check whether it is in 2NF or not. If it is not 2NF, then you have to make it 2NF, and then you have to make it in 3NF. So this is your home task. I will discuss in detail it will in my next lecture. You can work it down by your own, but I will discuss it in my next video lecture. And these are the references you may go through for further details on 2NF and 3NF.